Alright, so these are the valves.
Today we're going to be installing a drip irrigation system for our backyard self-watering garden, but this isn't your basic attached to the hose bib setup, so if you're curious about doing a professional grade install yourself, stay tuned to see how we tackle it. We started with a completely unkept backyard, overgrown and very neglected, but we were lucky enough to inherit some really beautiful mature trees. We worked hard to untangle them from the weeds and bring them back to life, so now it's time to make sure we have a system in place to maintain both the plants that are already in the yard and the ones we'll be adding as we go. For now, we're adding some wax leaf privets to act as hedging in some empty areas along the fence, so we'll be focusing our drip irrigation efforts on the perimeter of the yard, and we plan to add on to the system as we continue to plant up the backyard in the near future.
Alright, so these are the valves. These control when the water turns on and off. These are the filter slash regulators. One of each gets attached to a valve, and these regulate down from the normal 80 psi in the plumbing system to 25 psi for drip irrigation.
Drip irrigation involves placing tubing with emitters on the ground near the plants. The emitters slowly drip water into the soil at the roots. With a smart multi-zone system like the one we'll be installing, moisture levels are kept at a precise range per zone, ensuring better plant productivity and quality of growth. And there's no wasted water since it is reaching the roots of the plants directly, as opposed to spraying all over the yard. Since we're setting up a system to run directly from the house's water line in the crawl space, we dug a trench along one side of the house where we can tee the water off from its source, and send one section to the front yard and another to the valves for the backyard. Most homeowners doing this themselves opt for a system that hooks up to a hose bib because it avoids having to deal with any robust plumbing work. Lucky for us, working on this house for the past 3 years has made Aaron a pretty experienced DIY plumber, so we opted to tap directly into the main water line for a more seamless and discreet setup. But if you are planning to tee off from a hose bib instead, many of the same principles used here will still apply.
So I've got a 1-inch Pro Press tee. This is going to connect inline on our water main line. Basically, I'm going to cut out a section and jam this in. I just cut a piece here. This is going to go down into another tee where the water hammer arrestor will connect. This is a water hammer arrestor. This will go in the crawl space. This basically avoids the pipes in the house clattering when the valves turn on and off. Alright, so I'm going to use the manual press tool here. Just have to align the jaws. Make sure my pipe is deburred a little bit, just so it doesn't damage the O-ring. Start squeezing. Okay. This is called a pressure vacuum breaker. This is basically a backflow prevention device required by code to make sure that your irrigation water doesn't end up flowing back into the house plumbing system. We're going to do copper in, PVC out.
Here you can see the final setup. Water will flow from the main line in the crawl space up this pipe to the pressure vacuum breaker, and then down this PVC into the trench we dug, which carries the water to a valve box in the front and backyard. Once we were tapped into the water line, Aaron ran some PVC in the trench that will carry the water from the main water line to the drip valves. One section going to the front yard, and one section heading to the backyard system.
Alright, so these are the valves. These control when the water turns on and off. These are the filter / regulators. One of each gets attached to a valve. And these regulate down from the normal 80 psi in the plumbing system to 25 psi for drip irrigation.
We are going to have 2 zones for the backyard, so Aaron built a manifold system with PVC in order to supply both valves from the same line. There are pre-made manifold systems you can buy like this one that we did try at first, but we decided to make our own since we ultimately only needed 2 zones and space was limited in the valve box. First, we laid down a weed barrier and then added some gravel to hold it down and help with drainage.
That's pretty rough. And this is the valve box. This is what will cover up the valves that will be buried in the ground. Then I'll put the valve box on.
With the water supply set up, we were finally ready for the fun part, laying down some drip.
And this is the main 1/2-inch distribution tubing. Basically, this is a 500-foot roll of 1/2-inch drip line. And this is going to be run along our fences. We're going to run 2 of them along the entire perimeter of the fence. Each one of those will be connected to a separate valve at the sprinkler valve box, and that'll allow us to maintain a separate schedule for each of those lines.
The distribution tubing is just a way to carry the water along the perimeter of the yard, getting it to the areas of the yard that need watering. But in order to actually do the watering, we'll need to add emitters that tap into the main distribution lines and will be responsible for actually watering the plants.
Well, hopefully that's good. Should be on the way.
Okay. There it is.
Okay.
Okay. But before adding any emitters, we went ahead and ran the water to make sure our connections were working as planned. To cap off the ends of the distribution tubing, we use these figure 8 adapters, which essentially just create a kink in the end of the hose that stops the water. All tubing should be secured to the ground every 3 feet or so to make sure it stays in place. For the larger trees in the yard, we'll be using emitter tubing since the root system of these trees are already quite large and widespread. The emitter tubing will allow us to cover more ground, thereby more adequately watering the mature trees.
What this does, it has emitters, in this case, every 12 inches that emit 1 gallon per hour of water. It's pressure compensating, so in theory, as the pressure drops throughout different lengths of the system, it should maintain the same flow rate.
To connect the emitter tubing, we just cut into the main distribution tubing near the tree. and added a 1/2-inch barbed T that will reconnect the line at the cut and also provide a port that the emitter tubing gets plugged into. Then we ran the emitter tubing around the base of the tree and connected it to the T. Connecting these barbed fittings takes a little bit of force to ensure a snug fit, and you may need to do a little research to determine how wide of a root system any given plant might have so that you make sure to set the emitter tubing down in a way that will provide adequate water. Then we just used more figure 8 adapters to cap off the ends of the emitter tubing around the trees.
Bend it over and shove it in. It's a little tricky with the emitter tubing because the emitter is right here.
For our smaller plants, we'll be using individual emitters to provide a smaller, more focused supply of water.
Alright, for our ligustrum hedges, I'm going to be using some 2-gallon-per-hour drippers. So here I'd have the drip line, which is a 1/4 inch, the barbed fittings to attach to the supply line, and a hole puncher to put those barbed fittings in. So I'm thinking this should work for length.
For these smaller emitters, instead of cutting into the main line, we'll be piercing a hole in the distribution tubing and using a smaller barbed fitting to connect a 1/4 inch hose that will supply water to the actual emitter.
These are stakes for the emitters. Basically, you snap the tubing right close to the emitter, drive this into the ground, and it'll hold it wherever you set it. Keeps the emitter above the dirt so it doesn't get clogged.
With the emitters all in place, it was time to set up the smart controller that will manage our watering schedules. Most controllers are just timers telling the system when to turn off and on. A smart controller takes in a bunch of information and configures the correct amount of watering per zone. It's aware of the weather so it knows when it's going to rain and stops the system from running at those times. The controller we are using is the Ratio Pro series, but the non-Pro version would have worked just as well for our needs. It's just that the Pro one was on sale at the time, making it somehow cheaper than the Ratio 3. And, best of all, we were entirely reimbursed for the cost of the unit because of a government incentive in our area that encourages homeowners to install smart watering systems to cut back on overall water usage. So we actually ended up getting the unit for free, essentially, sort of. The Ratio will allow us to control and monitor the watering schedules via an app on our phones with no monthly fees. And it includes smart schedule changes so the system can automatically adjust for weather and season changes, saving water while keeping the plants healthy. They also sell a weather system, which we did not spring for, but it can read the weather in your actual yard for more precise adjustments. And wire-ready terminals on the unit makes connecting the electrical components easy.
This enclosure will house the sprinkler controller. Basically, I'm going to wire power in here. The power adapter sits in here, and then the controller installs in here. And then the line out to the valves comes out here. This will be in a conduit.
Supplying power to the controller required some crawl space rewiring. It is usually best to leave this kind of work to a professional, but if you are trying to do it yourself, please do your homework. There are a ton of videos right here on YouTube made by professionals who know far more than we do about rewiring electrical and adding outlets.
I got these lever lock connectors. They're good for making waterproof connections. I think it's basically just filled with silicone or something to keep the water out.
With power supplied to the controller, it was time to connect the valves. There's one wire per valve coming from the controller, which is what Aaron is connecting here.
Alright, that's connected. Pull out the common wires.
Then he connected the common wires, which go to both valves and completes the circuit.
Basically, just need to push all the wires up through this guy. Then snap this silicone-filled cap onto it. The whites are going to be common wires. Colored will be for the different valves.
Finally, we connected the controller using the manufacturer's instructions and installed it in the box, and we were good to go. If you found any of this info helpful in any way or just enjoyed watching, please like, leave a comment, and consider subscribing to our channel and allowing notifications to stay updated on our future projects.